I want to talk about how to use a graphical analysis program to get the data for our collision lab. So you should download graphical analysis from the self-serve app and open up graphical analysis. And it looks like this. You also need to download the file, the data file that is provided on Schoology. So you should download that to your iPad somewhere, or to Google Drive, or whatever you might want to do. And then you want to open that. So I have it downloaded, so I can choose the file here. So I pick choose file, and I have it on my iPad and right there. And you can see here that right now it doesn't give me anything. Up in the upper right left-hand corner here, you notice it says collision 2021 with the file suffix as it is. And I just want to show you the different places that we can work on. Over here on the y-axis, we have the choice of types of graphs that we want. We're going to do a position versus time graph, and we're going to look at the first one where the two objects stick together. So you could look at any one of them at any point in time. You could look at them as a velocity versus time graph, a position versus time graph. You could look at all three of them at once, which doesn't really do you any good. The position versus time graph gives us probably the best view of that. So over here on the left-hand side, on the y-axis, is where you choose the type of graph that you want and the data set. So you should have all three data sets provided to you, and that's what we got here. All right, and we see here, then we can zoom in if we want, we can highlight areas, we can look at actual values of different things and the times that things occurred. So the collision happened right about 2 seconds into the motion detection right there, and I'm going to X that out. Down here on the bottom left, right above the mode and stuff, this icon that looks like a little graph is where we actually do our analysis. And there's different ways to do the analysis. We can, for example, those of you that were in the hybrid learning this fall, remember doing this on the Lab Pros. We can apply a curve fit, and that doesn't look good at all right now. You would have to select the area that you want to find the curve fit to. So let's say I want to select this area and find the curve fit for the purple line there, which is vertical, or not vertical, but diagonal. The red line obviously is horizontal, so that represents the cart that is stationary at that point. Now, when I've selected that, I can apply curve fit, and you see it puts in a purple line there that seems to be along that. So it's a linear, it chooses a linear fit in that particular place. If you choose too wide an area, it will not fit very well. And I can hit apply, and I can see for both of the data sets what the information is using a y equals mx plus b formula, and m would be the slope. And this is a position versus time graph, so the slope would be my velocity. Now, that works fine and is great, but I found a better way to do it, and that is using the tangent. So if you hit the tangent, and then you just hit right here, it will tell you the slope at that point in time for each of the lines. So right there. Now, when we do the actual collision, we want to get the slope as close to the collision as possible. That seems to match up best. So obviously the red one here, the one that isn't moving, we would just put a slope of 0, and it actually gives us the meters per second, the units. And the purple one gives us a slope of 0.589 meters per second there. You might have a little bit different because you might choose a little bit different point in time, and that's absolutely fine. That's where the data acquisition is different for us. Then after the collision, record your velocities of each of these before the collision. Then after the collision, you record the velocities as well. Now, in this particular one, since this is when they stick together, I would say I'm going to record the velocity of just one of them and treat them as moving the same, because obviously these are a little bit different, and I don't know why, but we see it does tend to even out a little bit later. But since the purple one was moving and then moved after, I'm going to look at the velocity of the purple one and use that one, and that's going to be my velocity for both of them. As you can see, it does not quite match slope-wise, but I'm going to do that. For the other ones where they're moving separately, I would do this and use both of those numbers, but for the one where they're moving together at the end, I would just choose one of those two numbers. Okay, so then we can do the same thing with this situation. Again, I have a stationary one and a moving one. So right near the collision, I'm going to find the slopes. The stationary one I would write as 0 because it's obviously this is a little bit off. But the moving one I would write as that velocity. And then notice after the moving one changes direction, so we have a new slope that's negative, and the one that was stationary moves in the same direction that the moving one was going. So you want to write down those and keep track of direction. Finally, we can do the same thing with, choose the spring situation and look at the velocities there. Now, if you want to zoom in, you're welcome to zoom in. You could highlight and zoom in here, and that's no problem. And obviously there's no velocity before this, and then there's a velocity after. And you want to find where the slopes seem to be pretty close to where they are in the region, pretty close immediately after the collision. Once you have that data, then that's the main reason we're doing this. We don't need to use this app anymore, and you can use the information to do the data and analysis for the lab. All right, I hope that helps. I will talk to you later this week. Thank you.